Welcome to the Deep Dive, the place where we turn complex information into crucial, actionable insight. Today, we're stepping into a really high-stakes situation. Imagine this. You're the Pittsburgh Development Corporation, the PDC. You've got this prime piece of real estate, and you're planning a luxury condo complex. We're talking units that go from, $300,000 up to $1.4 million. But the big question, the multi-million-dollar question is, how big do you build? Because that choice could lead to massive profits or, a truly catastrophic loss. You've given us some great sources on decision analysis, so our mission today is to use this PDC case to walk through a structured way of making these kinds of calls. We're going to get past the gut feelings, really define the risks, and figure out how to build the best possible strategy when the future is, a total unknown.
And what's so powerful about this approach is that it forces you to lay everything out on the table right from the start. Before you even touch a calculator, you have to define three key things. First, the decision alternatives. What can you actually do? Then the states of nature. What might happen in the future that you can't control. And finally, the consequences or payoffs, the cold, hard profit or loss for each combination.
Okay, let's start there. Let's unpack it. What can the PDC actually control? What are their decision alternatives?
They've basically narrowed it down to three architecturally sound options. We can just call them D1, D2, and D3.
So a small, a medium, and a large complex.
Exactly. 30 condos, 60 condos, or the big one, 90 condos. Those are their only moves.
And what about the big unknown, the market factor they can't control at all?
Well, it really boils down to two possibilities, two states of nature. We'll call them S1 and S2. S1 is strong demand for these luxury condos. S2 is weak demand. And the whole problem is that they have to pick a size before they know which one it's going to be.
Which brings us to the payoff table. This is where you see the numbers and the risk just jumps off the page.
Let's look at those payoffs. The small complex, D1, is the safe play. It makes $8 million if demand is strong, and it still makes $7 million even if demand is weak.
Low risk, but, relatively low reward.
Right. Now, if they go medium, the potential profit jumps to $14 million with strong demand. And if it's weak, they still clear $5 million. Pretty respectable.
But here's the real gamble.
Yeah.
The 90-unit large complex.
This is where it gets really interesting. If demand is strong, one, they hit the jackpot, $20 million profit. But if demand turns out to be weak, it's a disaster, a $9 million loss.
Wow. A $20 million upside versus a $9 million hole in the ground. That table really just lays the dilemma bare. Is that huge reward worth the catastrophic risk?
Exactly. The payoff table is the map. Now we have to add belief. The PDC has to assign probabilities to those outcomes. How optimistic are they right now before any new data?
And their team is feeling very confident. They've put an 80% chance on strong demand. So P of S1 is 0.8.
Which leaves only a 20% chance for weak demand. P of S2 is 0.2. That's a very optimistic starting point.
So how does that optimism factor in? What's the next step?
The next step is to calculate the expected value, or EV. You can think of it as, it's the average profit you'd expect to make if you could repeat this decision many, many times, all weighted by those probabilities.
Okay, so we're weighting the payoffs with their 80-20 belief. Let's run the numbers for each option.
For the small complex, it's pretty straightforward. You weigh the $8 million and $7 million payoffs, and you get an EV of $7.8 million. Stable, but not exciting.
And the medium one?
For medium, you do the same thing with the $14 million and $5 million payoffs. The math works out to an expected value of $12.2 million.
Okay, now for the big one, the large complex. We weigh that huge $20 million win by 80%, but we also have to account for that painful $9 million loss.
And when you do that calculation, the expected value for the large complex comes out to $14.2 million.
So even with that huge potential loss, their optimism is so high that building large is actually the best choice.
Based on their current beliefs alone, yes. Without any more information, the decision that maximizes expected value is to build the large complex. We call that the expected value without any new information.
But wait a second, $14.2 million is the expected value, but that $9 million loss is still a very real possibility.
Yeah.
So how much would it be worth to them to eliminate that uncertainty completely?
That is the perfect question. And it leads us to our next concept, the expected value of perfect information, or EVPI. We're asking, what if PDC had a crystal ball, an oracle that could tell them with 100% certainty what demand was going to be before they ever broke ground?
If they knew the future for sure, what would they do?
Well, the decision becomes trivial, right? If the oracle says strong demand is coming, they obviously build the large complex and make their 20 million. But if the oracle says, warning, weak demand, they'd pivot. They would build a small complex and guarantee a $7 million profit, avoiding that huge loss.
Okay, so we know the perfect choice for each outcome. How do we get the expected value of that perfect strategy?
We just weigh those perfect outcomes by their original probabilities. So there's an 80% chance they'd be told strong demand and make 20 million, and a 20% chance they'd be told weak demand and make 7 million. That gives us an expected value with perfect information of $17.4 million.
$17.4 million. That's the best they could possibly hope to average. So the value of that perfect information, the EVPI, is the difference between that and what they expected before.
Exactly. You take the 17.4 million and subtract their original 14.2 million. The difference is $3.2 million.
$3.2 million. So that's what the uncertainty is costing them, in a way.
It's the maximum they should ever be willing to pay to get rid of all uncertainty. And since that number is so big, it's a huge signal that maybe they should invest in getting some information, even if it's not perfect.
Which leads us to the real-world scenario. They consider paying for a 6-month market research study. It's not a crystal ball, but it'll give them a report, either favorable or unfavorable.
And this is where things get really powerful. This new information, the sample information, requires us to update our initial probabilities. That 80-20 split was just a starting point.
So this is where Bayes' theorem comes into play. It's the mathematical engine that lets us blend our old beliefs with new evidence.
That's right. And to use it, we need to know how reliable this study is. The sources say it's pretty good. For instance, if demand is truly going to be strong, there's a 90% chance the study will correctly predict that with a favorable report.
And if demand is truly weak, it has a 75% chance of giving them a warning, an unfavorable report.
So when you feed those numbers and their initial 80% optimism into Bayes' theorem, the probabilities shift, sometimes dramatically.
Let's look at those shifts. What happens if the report comes back favorable?
If the report is favorable, their confidence in strong demand skyrockets from 80% all the way up to 94%. They're almost certain.
And if it's unfavorable?
That's a whole different story. If the report is unfavorable, the odds flip. The probability of weak demand jumps from just 20% all the way up to 65%. That high-risk gamble suddenly looks terrifying.
So now we have these new, updated probabilities. We can map this whole sequence out on a decision tree. First, the choice to do the study or not, then the result of the study, then the final choice on what to build.
And the key to solving a decision tree is to work backward from the end. You start with those final decisions after you've already seen the report.
Okay, so let's say they did the study and the report came back favorable. What's the best move then?
With 94% confidence in strong demand, you go big. They choose the large complex, and the expected value at that point is $18.26 million.
But if the report is unfavorable, the alarm bells are ringing.
They are. With a 65% chance of weak demand, the large complex is too risky. The math shows the best choice is to scale back to the medium complex. The EV is lower, 8.15 million, but it's positive. They completely avoid that $9 million loss.
Okay, so now we know the best plan for each possible research outcome. How do we figure out if doing the research is worth it in the first place?
We roll it all back to the beginning. We calculate the overall expected value with the sample information. There's a 77% chance the report will be favorable and a 22% chance it'll be unfavorable. So we just weigh the outcome values we just found.
Right, so it's 77% of that 18.26 million plus 23% of the 8.15 million.
And that gives us a total expected value for the conduct the study path of $15.93 million.
$15.93 million. Now we can make the final comparison.
The choice is clear. At the very first decision node, they have two options. Path 1, don't do the study, just build large, with an expected value of $14.2 million. Path 2, conduct the research study for an expected value of $15.93 million.
So the optimal decision is, without a doubt, to conduct the market research. The information literally adds value to their bottom line.
And we can calculate exactly how much value. The expected value of sample information, or EVSI, is just the difference between those two paths, $15.93 million minus $14.2 million. The study itself is worth $1.73 million to their decision-making process.
Almost $2 million. That's the value of adopting this data-driven dynamic strategy instead of just sticking with their initial gut feeling. It's amazing. We went from a recommendation to just go for it and risk a $9 million loss to this nuanced strategy that protects them from that disaster and actually increases their expected profit.
And that's the final takeaway. The optimal strategy isn't just one decision, it's a plan. It's conduct the research. If the report is favorable, then build the large complex. But if it's unfavorable, you pivot and build the medium. And what's really important to consider here is that this framework, it's not just for maximizing profit. We've been talking about millions of dollars. But what if the consequences were something else? What if it was about reputational damage or environmental impact or long-term market share? This same rigorous process forces a manager to confront those non-monetary outcomes, to assign them a weight, and to factor them into the decision right alongside the financial payoffs. It's a tool for clear thinking in any complex situation.
That is a powerful point. The real benefit isn't just the final number, but the clarity you get from defining your choices, quantifying your risks, and using new information to adapt. We hope this deep dive helps you apply some of these concepts, payoffs, chance events, and expected value to the next big choice that you have to face.